Okay, so we solved some examples related to rate of change. First, I will explain something. Let's say before we are doing that, y equals to, let's say, 2x plus 3, and we were saying that take the derivative. When we were saying take the derivative, it was understood that we are finding its derivative with respect to x. So we were writing that d by dx y 2 times d by dx times x plus d by dx times 3. So it was dy by dx equals to 2 times derivative of x was 1, derivative of constant was 0. So dy by dx was 2. So similarly, if I say that, like in your midterm there was a problem like y equals to minus, to find its derivative with respect to y. So when we were saying that find its derivative with respect to y, it means that differentiate with respect to y. So now you see, when these two variables are same, then we take its derivative by applying the power rule. When these two variables are not same, then this variable multiply with this d, it becomes dx by, and this variable remain as it is. Like here you can see these two variables were not same, so it becomes like this. And when these two variables are same, we apply the power rule which we normally use to apply. So now these two variables are same, so we apply the power rule. Minus 2 will multiply with the coefficient of variable, and we will subtract 1 from the power, and derivative of the base is y, its derivative is 1 with respect to y. So it is dx by dy was minus 2 y raised to power minus 3. So similarly, there was another problem in your exam, which was I think y equals to 4y square 2y minus 1 over 2y minus 3 or plus 3, whatever it was. So some people were applying the quotient rule, but that was also correct. But since we didn't discuss quotient rule, so you can simply, it was very simple, you can write it like this: 2y over 2y minus 3 minus 1 by 2y minus 3. This minus y3 will go up, it will become 2y 2 plus 3 plus this 2 will cancel out, it will become y 1 plus 3, and it will become 1 by 2 y raised to power 3, which is 2 y raised to power 5 y raised to power 4, 1 by 2 y raised to power 3 equals to x. Now if we take its derivative, it will become dx by dy 10y4 plus 4y3 minus 3 by 2y2. I am taking its derivative like this. So now we are coming back to the rates related rates. Related rate means that we always take the derivative with respect to t. We always take the derivative with respect to t. And rate of increase means, for example, if I say rate of increase in the cost, if I denote cost function with c and I say rate of increase in cost, it means that dc, I am talking about dc by dt. If I say, if I denote revenue with r, and it says that rate of increase in revenue is dr by dt. Whenever he talks about the rate of increase of certain thing, it means that we are talking about its rate of change, like differentiate with respect to t. If you producing x number of radios, X number of radios per week. And if I say rate of increase in the production per week, it means that rate of increase in the production, we are denoting number of radios, number of production with X. So rate of increase in the production, it means we are talking about dx by dt. So this is how we denote rates. So for example, in your book, question number 9, in question number 9, it says that find dx by dt, find dy by dt when dx by dt is 3, x is 5, dx by dt is 3. Find dy by dt when y equals to x square plus 2. So dy by dt, d by dt, x square plus d by dt, this will be dy by dt. As I said, when these two variables are not same, first we take the derivative. Normally we used to take derivative of x square is 2x. Now the base is x and function is base is x, and the derivative we are taking with respect to t. These two variables are not same, so it becomes dx by dt. So this is dy by dt. So dx by dt was 3, x is 5. You can substitute it and you can get 30 as a result. So this is how we find the derivatives of rate. For example, I solve one more example. Let's say you are given a function y equals to 2x square plus 3z square. We want to find its derivative with respect to t. So d by dt y to d by dt x square 3 d by dt z square. We always take the derivative of power as we used to take. Since here power is 1, so and these two variables are different, so its derivative will be dy by dt. Here first we take the derivative of power, which is 2. 2 will multiply with the coefficient of base, subtract 1 from the power, and then we take the derivative of base. Now base is x. We have already taken the derivative of power, so we don't write power. 3. Similarly here, first we take the derivative of power, means multiply power with the coefficient of base and subtract 1 from the power. Now we take the derivative of base. Base is z, so it is 4x dx by dt plus 6z and dz by dt, and this is dy by dt. So this is how we take the derivative of related rates. We solve one example from the book, and let's see how it goes. For example, related rates. Here the price and demand x for a product are related by 2x square plus 5xp plus 50p square equals to 80,000. So here we are asked to find, in part, if the price is increasing at the rate of 2. Price, we are denoting price by p, and price is increasing at the rate. So dp by dt is given 2. When the price is 30, when price is 30, find the rate of change in demand. Demand is dx by dt. Rate of change in demand means we are finding dx by dt. So we differentiate it, it will become 4x dx by dt plus 5 here x times p. We apply the product rule. We apply the product rule and I explain how do we apply product rule. 5 x as it is, derivative of p dp by dt. Now p as it is and derivative of x dx by dt. Here it is 100p and dp by dt equals to 0. 4x and dx by dt we want to find out, plus 5x dp by dt is 2, p is 30, dx by dt we want to find out, plus 100, p is 30, dp by dt is 2. So this is how we can find the dx by dt. You can take dx by dt common, you can get the expression for dx by dt. So before solving more problems related to the rate, I would more like to solve some differentiation properties like quotient rule and product rule. When you are given two functions like y equals to u times v, then when we take its derivative, first we take the derivative of u function plus then u times we take derivative of v function. For example, let's say y equals to 2x plus 1 and x square minus 1. You can say this is u, this is v. We have product of two functions. So dy by dx will be v as it is, derivative of u plus u as it is and derivative of v. So it is x square minus 1. Now derivative of 2x plus 1 is 2 plus 2x plus 1. Derivative of this is 2x. You are done. If you want to solve it further, you can multiply 2 inside. It is 4x square plus 2x. So it is 6x square plus 2x minus 2. This is dy by dx. Similarly, uh, if you have two functions in quotient form like u by v, then its derivative is dy by dx. First we write v, derivative of u, then minus u as it is, derivative of v divided by v square. For example, I take the same function 2x plus 1 over x square minus 1. Now you have function in the quotient form, so its derivative will be dy by dx, v as it is, derivative of u which is 2x plus 1 minus 2x as it is, derivative of v. So x square minus 1, derivative of u is 2 minus 2x plus 1, derivative of this which is 2x. So if you and divided by v square which is x square minus 1 whole square. So you can write it 2x square minus 2 minus 4x square minus 4x over x square minus 1 whole square. So this is how we deal with when you are given product function and a quotient function. So we try to solve one more example for the rate problems. Like let's say, suppose that a company manufactured the flash drives. We have solved this example in the PPTs as well. 5000 plus 2x R is 10x minus 0.001x square, and P is R minus C. The production is increasing at the rate of 500. We are denoting production by X, so production is increasing at the rate of 500, so dx by dt is 500. And when the production is 2000, find the rate of increase in cost, rate of increase in revenue, and rate of increase in profit. So rate of increase in cost is dc by dt, which is 2 times dx by dt. So 2 dx by dt is 500. So rate of increase in the cost is 1000. Similarly, dr by dt 10 dx by dt minus 0.01 times 2x dx by dt. You can substitute x and dx, you can get the rate of increase in the revenue. It would be 3000. And likewise, you can find the rate of increase in the revenue, in the cost.